enjoy today's class. Okay, so at Data Science Nigeria, we have vision to raising 1 million AI talents and build AI solution that improves the quality of life and well-being of 2 billion people in the emerging market. Yes, and then we do this through our renewed focus and through these 3 core areas, which are community for learning and research. I am sure you are aware of our communities here. We have over 80 communities spread across the globe that do learning and that do research. So if you are not a member of DSN community, it is time for you to become a member of DSN community. So what we do is we learn and also we carry out researches, global researches that meet conferences. You know, as I go in introduction, I will be showing you examples of researches that we have done and even those ones that have won award. So another area that we focus on is the product development for social impact. Yes, at DSN we have our product that we have conceptualized and designed for social impact, and a lot of our products have also won several awards. Partnership for solution delivery, this is also what we do as part of our core areas towards to raising 1 million AI talents and building AI solution that will improve the quality of life of the 2 billion people in the emerging market. Okay, so over the years we have evolved, and we have evolved from learning our community to startup, to research, good application, and we are doing extremely good in this ecosystem. We are doing extremely well in this ecosystem. DSN has won different awards, and one of it is the Matter Impact Award at Deep Learning 2019, where we won the #1 artificial intelligence learning community delivery network in Africa. Yeah, we won the #1 artificial intelligence learning community and solution delivery network in Africa. Yes, and also we won the best academic poster at the 21st edition of the Global Economics and Competition Conference. Yeah, yes, the poster was on shared trust to end poverty and promote financial inclusion. Also, DSN was the only African finalist at the 2021 X Prize competition on building advanced AI algorithm to solving COVID-19. So we are the only African finalist at this competition. So we have presented our academic paper at foremost global scientific and practitioner AI conferences. And we are the one to release the first artificial intelligence and Python book for elementary students and beginner in Africa. Yeah, so I recommend this book. You need to get one. You can get one for yourself and even get one for your kids. So using this link, you can get a book, this interactive and engaging book. So don't miss out. So you can just use this link to order for your own copy. So we have a dedicated AI research lab that's located at Yaba, Lagos. Okay, so you can come visiting, come take pictures, come see the library, come see robotics lab, beautiful stuff that we are doing here. So you're welcome. And then we also offer a co-working space that you can book. You can also come and read. We have a library well equipped with books, mind-blowing books that can actually push your career forward. So you just come and then come and make use of these facilities, these resources that we have made available for you at our AI research lab at Yaba. So 2 of our products initiated and conceptualized by DSN, was one of the top 100 AI products by UNESCO. I have seen, it's exciting, it's awesome, right? Okay, so to show that it's awesome, I want to see your reaction in the chat box. So let's just see a reaction. Yeah, our 2 products who won this were one of the top 100 AI product by UNESCO. Yeah, so our two products are the educative EduTech AI adaptive learning engine and prescribed rights. Okay, so this has dual business model for global impact through DSN AI innovation. Okay, and also at DSN we incubate startups. So these are the startups that were incubated by DSN in the past years, and also be looking forward for the next cohort. Okay, so if you have an idea, want to build a product, want to start an organization that is artificial intelligence based, DSN AI incubation is a go-to for you. So you just watch out for our application, our registration form, so that immediately this is out, you can just get yourself registered. Now we are not just, there's a saying that goes thus: I can see farther because I'm standing on the shoulder of a giant. Yes, we are supported by world-class advisory board. Dr. E. Stewart is our chairman, with a lot of intellectual authority in the industry, we're coming together and forming our advisory board. So you cannot expect less from us. So moving straight to today's event, I would like us to quickly meet our speaker. I would like to introduce our speaker, and then afterwards I can hand over the mic to our speaker to start the training section. Okay, so Bilikisu Olawumi Olatunji. So she is the founder of Business Data Laboratory. Okay, she's also the lead, the product development team at as a data scientist. She leads the product development team as a data scientist. She's also the co-founder, the co-organizer, and the founder of Abuja Our User Group and Our Ladies Abuja. Bilikisu is a certified Art Studio instructor for TDVAS and Shining application development. She has interest in geospatial data science and has been working on several related projects using her. As an independent consultant, she's a certified Scrum Master, product owner, and Agile coach. Please, I want to employ you that with your favorite emoji, please let's do this. I want to welcome Bilikisu Umi Olatunji as she takes the mic and starts the training. Thank you very much. Please, I need your favorite emoji in the chat. Please, let's use this to welcome our facilitator for today's session. Over to you, Bilikisu.
Okay, thank you so much, Tejumola. Thank you so much. I really appreciate that warm introduction. So thank you everybody for joining us today, and I'm really excited to be here as well. So without wasting much of our time, I would share my screen, and I would also be taking away the video for now because of the fluctuation in the internet. So we'll be facing my screen, so I'm going to share that, and please just let me know. Okay, kindly let me continue. Maybe you have to stop sharing so that I can share my screen. Okay. Okay, so please kindly confirm if you can see my R studio. So let me know if you can see that. Okay, thank you so much. Thank you. Okay, so good afternoon once again, or good day to all of you joining from all over the world. That we have a large network here, Data Scientist Network. So I would go off the camera, then we'll start. So today we're going to be looking at an introduction to interactive map for business data visualization using R. I'm an R addict, so that's how we're going to be using R today. So I'm passionate about using R, and I've used it in so many projects, and I'm here to share my knowledge with you. So a lot has been going on this week on geospatial data analysis. We can't talk about interactive map without talking about geospatial data. So today I will be taking us through an agenda that will be looking at basic understanding of geospatial elements. So access to geospatial data sets from various sources. So import, we're going to import geospatial data into our R section as well as yours. So we transform the data and also get it ready for visualization. So when at the end, we're going to have a beautiful informative map that is interactive that we can build upon as we practice using R and also creating visual maps that can be of business value. So maps invariably has been doing a lot in helping businesses these days. And it helps in so many ways in various sectors, health, retail, transport, and all this stuff. So all these business aspects, geospatial data is very key. So having an interactive business application that is based on interactive map would really be of beneficial to the business. So, and also for the current ongoing competition that we're looking at geospatial data science that DSN is actually organizing, I think this will be a right tool for you to add to your portfolio. So I'm not going to take much of our time. So I'm going to go a bit into geospatial in R. So we would use some of R packages. When I talk about R packages, we're talking about collections of functions that they're having related uses for different tasks. That's what we call packages in R. So different packages are created for different use and different needs. So some of the packages that we're going to be looking at is Tidyverse, which is basically for doing data science, like data analysis, cleaning our data and getting it ready for analysis. So VROOM is also for getting our data into R. So this is more or less an advanced package for importing and working with data and also getting it in the right format. So we are going to be much more particular about SF, that's simple features package, and tidy geocoder, as well as the map view packages. So these packages are for our geospatial interaction, creating maps that are interactive. So some of the documentation are in the reference in this file, which I'm going to share with us later. So we're going to look at different parts of geospatial data. So we'll first of all have to look at how is data represented when we're talking about maps. So we have two much more common representation. We are talking about vector and raster. So vector, when we're talking about vectors, we are actually looking at a 2D representation of our points. So it could be, and it's basically recognized as an irregular polygon. So with points that are helping us to define the vertices of our polygon. So a squared, like a square example would be a squared plotted shape with Cartesian coordinates. So this could be an example of a vector representation. Also, we have the raster, which is actually not is regular for the representation, but it's not so much used when we're looking at the map, but we can get its relevance more when we're talking about graphics like JPEG, TIFF files. So raster are good for graphics. So, but the main difference here is that raster, as we said, are great examples when we are looking for details as seen in pictures represented using pixels, but they do not scale. They do not scale well. So while vectors are great for things that need to be scaled, that we're talking about points. So geospatial projects are kind of almost always done in vectors representation. So because it's easier to store data as vectors, and also it is easier to manipulate, project, intersect, and connect vector points, lines, and polygons. So today we're going to focus more on vectors. So now we're in the R Studio. So I'm going to take you how we can interact with the vectors, points, polygons, and so on in R. So like I said, packages are a collection of functions that we can use, that we can create by ourselves, or is created in the R community. A lot of support are there in the R community, where packages are created to help us solve mostly all the problems that we want. So R is very, very simple to learn, and the learning curve is kind of better compared to other languages. So I would want you to kind of give it a try and like kind of come into use R. So we're going to look at these packages. The tidyverse is for data science, the data, all the tasks that we do when we're working with in data science, like and manipulation, importing our data, and so on. Then VROM is also to read delimited files faster into table. So that's what we call data frame. So then we're using the tidy geocoder for geocoding. Then the simple feature package itself, we're using this to create simple feature objects. Then we're also going to be using the map view for the interactive maps. So I'm going to load this. For us to use it, we have to run this line of code. So to give us access to use the functionalities that are in these packages. So for you to use any package, you have to kind of install it first into R Studio. So it's just about saying, just basically saying in install packages. If I'm going to take VROM, that's faster. So this just help you to load every functionality in this package into your R Studio environment. So this will help you to use all the functionalities there. So I'm going to comment out this since I've had all these packages installed. So vectors here, we've talked about the theoretical aspect of vectors. So here I'm going to show you all the various types of vectors that we're having through the simple feature geometry types. So we're going to be looking at points, line strings that we're talking about joining 2 points together. We're going to be looking at polygons that's formed from the connection between the lines. Okay. So, okay. So we also have multi-points, multi-line strings, and then we have multi-polygons, geometric collections. So I'm not going to go into all this, but I'm going to take some of this. So when we're talking about points, this could be, in basic layman's term, location of places like hospital, maybe in Agege in Lagos, or a location of a kind of a Lassa fever case. Maybe there's a case of Lassa fever, maybe in Jeshatedo or something. That could be a point, a geographical point that we might be looking at. Then we can also look at location of major intersections within localities. So these are examples of points. So, and when we want to represent this in R, we're looking at creating these points. We're going to be looking at what we call, for those who are familiar with geography, we're going to be looking at the latitude and the longitude. So we're looking from that will be vertical for the longitude, then the latitude is going to be horizontal. So that's the dimension now. So for the first one here now, we have the 2 points here for the latitude and the longitude. So these 2 points has to be what we're referring to when we're talking about our points. Without these 2, we can't have a point, because it's a reference that is going to be a location between the latitude and the longitude now. So we wouldn't want to kind of just look at the longitude. It's not going to make sense because both are intersecting. to give us that point. So the function that we're going to use is going to be from the SF package, that's the st_point. So this is from the SF package, as you can see on the screen here. If you want to have more information about it, for those who are familiar with that, we just need the question mark here, and it's going to give us the documentation on what we can use this function for. So it creates simple function and feature from a numeric vector. That's why we're having this vector supplied in as an argument to the function st_point. So if I have these 2 points now, my latitude, my longitude, if I run this, it's going to give me a point. So as you can see on my console here, we have the point here. So which is having both the latitude and the longitude value being represented. So this is just basically what we have, and we can save it as a variable. That will be our point A. So if we now want to go ahead and view it, maybe on a map, you can go ahead and use the map function from the map package. So that is what we're using the pipe here to pass in the argument for this function. So it can also be like this, map_view. Map view, sorry, just view. So this, we can push in the point A instead of using the pipe. So it's still going to give us the same thing. So it's going to give us the point on the background, which is kind of representing the canvas, that's the map base here now. So this is a point here. It could be an hospital, okay, or a marketplace, anyone, that may be a house. So we're going to look at getting location of the data science office in Lagos. So these are the ways that we can view the points here. So it's the same thing as what I've done earlier. So if we want to look at multi-points, that's we are having multiple points, maybe house A, house B. So we can have this combined together. So I'm having another point here that I'm representing as point B and point C. So these two, if you want to view what is there, you'll see the 2 points. So they are there. So these are going to be combined as a vector now. So we've already said that point is a type of vector that we can work with. So I'm going to combine them as a single vector to give us multiple points. So if I run this line, so it's going to give us a vector, which is point A, B, C. So I'm combining point A, point B, and point C together now. So it can be, I'm joining house A, house B, house C together. So if we want to view that on the map, we'll have all the 3 locations that are represented within the vector. So that's what we can see on my map here. Okay, in the viewer, so you can see all the points are there. Okay, so we have them represented here. So that is for multiple points now. So moving on, we'll still have functionalities that we can use. Since all these points are just dots on the map, we can combine them, link them with a line string. We join them together using lines. So this is where the SF function comes. So if you look at st_cast, so it's from the SF package. So this is also from here. You can get information by just putting the question mark here to see for more ways that you can use it. So now I'm going to pass this string, the vector containing the 3 points. So I'm going to pass that into the cast function. So it's going to help us to join the lines together as a line. So, but you'll see the points there when we view it on the map. So with this line on line 54, we're actually creating a variable line ABC from the points ABC that have been combined together as a vector. So we're asking this function, we're piping it into, we're giving it to this function to help us convert it to a line string. That's why this argument is in the brackets. That's for the function now. So I'm running this line, then I will have this object, this variable now that is containing all the 3 points. So 1, 2, 3. So now we want to view it on the map. So we have the 3 points joined together. You can see the dots are not there because they've been combined together now. But if you now want to add that, then we'll have to go for the next line of code, which is going to have the line displayed on the map as well as the points. So all are going to be embedded together. So you'll see what I mean by that now. So we have the points being represented with the circles and the line also joining them together. So if you have any question at this point, you can put it in the chat box, then I'll attend to them maybe during the section or after the session. So we now want to look at multiple lines, line string that we can combine together. So also we can use this line string. So combining this R function is just to combine all these vectors together. So I'll have an object that is saved here. So now I want to combine them. Okay, so we're going ahead. If you look at, we can view what we have now. LS. So this is what we have as a line string, then the inverse now. This is another one. So we want to look at how can we join them together. So I'm going to combine everything here with the st_line string. This is what we have. Then we want to view it on the map. So we have a different shape now with these different points. All these locations are gotten from Lagos. So it's just a street that is like a square shape, but I'm just selecting the points. So that's just what we're doing now. So this is the second one. So we have the points RST, then we have the XYZ. So now if we are going to look at, okay, kind of joining the two together, we'll have to combine them as a vector before we now view it on the map. So we now see the two different line string, multiple lines have been joined together in this zigzag. This is a street in Lagos, is a vicinity in Lagos, which I can't remember, but I just select all those lines. So, but I'm now going, because the reason why I need this is this. We have some points, location here, but we want to look at what is a polygon. We're looking at selecting areas within some points to make a certain polygon. So we might be looking at, okay, between house ABC or house RST on this street, we want to kind of select the area as a polygon that we want to kind of analyze everything that is around that area. So if we're looking at a school and we have an abattoir close to it, we take that point. We have a school, we have an abattoir, and we have a marketplace. We might want to select those areas as a kind of a polygon. So that is where we're going to now. So a polygon could be LGA boundaries. Okay, please, I'll attend to the question. Let me just complete what we have here. I'll attend to this question. Yeah, we're going to share the video and the document, but I'll attend to you later. Thank you. So the polygons could be a local government area boundary, okay, a school perimeter, or a dumping site. So that land mass around that dumping site, whatever is around it, we're kind of looking at those areas that we want to select. So with these lines that have been joined together, we can create a polygon because there are different points that are now joined together, but they are around a certain landmass or a certain space that we can kind of now tag as a polygon. So this is now where we're going to cast, not as a line string now, but as a polygon. So I'll cast this, then we'll view on the map. So you can see for the lines now, we have created, been able to create 2 polygons out of this, because we have 2 line strings that were connected that are now joined together. Now we're able to now create a polygon that was selecting the area around those points. The first one, that's the RST, and that of the XYZ. So this is the way we can, so that area can now be analyzed, all the data that we have there, we can analyze them and kind of make sense of what is going on there. So since this is an introductory section, so we're not going to go into that deep aspect of this geospatial analysis and making maps, but we'll get there. This is a way to create the foundation for that. So moving on now. So want to understand geocoding and reverse geocoding now. This is the interesting part. We've understood what we want to tell us about vectors, the points, polygons, line string, multi-lines, and so on. But I mentioned that we have also multi-polygons, then geometry collections. We're not taking that here. We just want to take the basics. So we're going to go now into all these points, their address. A layman would not understand what is called a point, like a latitude or longitude, but he would understand an address. So I'm taking an example here, the University of Lagos, Akoka Yaba, and then the data science DSN office in Yaba as well. So if I say, okay, I'm going to DSN office at 33 Queen Street, Alagomeji, Yaba, Lagos, that is understood by layman. But if we're talking about maps, geospatial data, we'll be talking about points, where it is located on the map. The house or the building is located on the earth, which can be represented on the map. So, and if you want to have that representation on map, you need geo points that is representing that address. So here we're going to be using some functions here. So the geo function here, if you look at the documentation, so it's from the tidy geocoder. So this package helps us to create points, that's vector points, that is representing that address. So I can give it either I give it the address or maybe the name of that building. If it's that popular and has been captured in the OpenStreetMap, we will be able to get this. And if we're still looking at what I'm having here, we're using the ArcGIS as the option, the method to get the location here. So we can use the OpenStreetMap packages that are related to that to help us to get this information. So here I'm giving it the first argument here is the address. Okay, so I'm using this method, ArcGIS. So if I run this now, I'm going to, it's trying, you can see it's trying to, it's going through, okay, let me clear my console. I will do that again. So what is this? You can see what it did here. It's kind of going through the internet, or they're trying to get the information about this address. Mind you, this is an estimated point. Sometimes it's not that accurate, like, okay, this is the actual thing, but we're looking at very, very close. So that is it, 100% is being able to get us the information so fast. So the address is there, and this is the assumed location points. That's the latitude as well as the longitude value. So it's been able to create that for me. So I can use that on a map. I can mount that onto a map now. So also let's try that of the University of Lagos, Akoka. So the same thing is, they're very close. You can say it's Yaba, and the latitude is for DSN office 6.50, while that of University of Lagos is 6.52. So that is sorted out for me. So if I want to represent this on the map, it's easy. So I can just take the two, pass it into, maybe create a table out of it, as we're talking about a better version of data frame. So this is what I've done here. So if I select this, so I have like a table of values containing the latitude and the longitude values for the University of Lagos and the DSN office. So now what I want to do now is I want to reverse it. Let's assume, okay, I don't know the address, but I want to kind of look for a way of getting this address. I have the points. Maybe we've collected somebody used a device, maybe a phone, to collect information, and the point information data, geospatial information about that location has been captured, and we don't know the place. So we can approximately get the address of that location. So just like what we're talking about, the Facebook data, we can take the latitude and longitudinal values there and convert it to address that we can make sense of. Okay, which states are this? Does this location belong to, and make sense of that data? So because it's not captured, is a privacy kind of very unique and different, that okay, the privacy is actually preserved. So, but we can guess, if you want to work with it, you are signing up, you are abiding by the terms and conditions, then you know what you can do with it. So now I want to reverse it. I have the latitude and the longitude. I want to guess the address by using the reverse underscore geocode function, this function. So I just pass it the latitude value and the longitude. So now we're using this method, OpenStreetMap, OSM. So it's going to help us to get the full detail about it. So if I select this without taking the last pipe, it's going to help us look through its data, but a lot of information are not going to be displayed here. So I'm going to view it as a table like the Excel format, using this function view. So I will run this so that we can see all the information that is going to give to us. So this is the information that is passed back to us. So you can see the address here is guessed right, but the number of the building is not there. So it's Queen Street. It knows that this location is on Queen Street, Yaba, Lagos mainland, Lagos. Yeah. So that's Lagos. So it's giving us also the postcode, and it's in Nigeria. So that's the license there is there. So we have other information. So the data belongs to OpenStreetMap contributor. So those who are volunteers, they get those information for them. So we also have other information, village, county, and all this stuff. These are not related so much to Nigerian context, but it still have other information. The Lagos is there, postcode, and all this information. If it's required by you, you can get all this information here. So you can see Unilag Central Mosque. I think the volunteer captured that the point information, the location information from Unilag Central Mosque. That's why it's given the description there. So that is that. So it's an approximated, very, very close. You can say, let's say 99, or let's say 95 accurate there. So let me check the charts. Okay, thank you. So now we're going to look more into simple features. So for you to work with simple features, now we've been talking about, okay, we're looking at longitude, latitude. When we're looking at simple features, we're looking at geometry, and which is a combination of the latitude and the longitude, and now put in a certain data type that is understood as a simple feature. So here we can do this. Although we have the latitude and the longitude, we can convert it to a geometry using this function, st as sf. So that means we are taking this data. You can get more information about the function. So it's going to convert it as a simple feature for us. So this is converting foreign object to an SF object as a simple feature object. So this is what is much easier, and that's the kind of the standard for geospatial analysis now in R. So simple features actually really helps us better understand the data, and most of these geospatial data are actually captured as what? As geometries, simple feature data types. So we're going to get there. So, but this function helps us to do this. So if I run this code, we're going to have a geometry created for us. So it's on the points that we have, and this is now what we get back. So that is what we're going to have on our map. So moving on, so visualizing the line now. So we have this already converted into a geometry. You can view it by piping it to the map view function that we've been using for a while now. So these 2 points are now represented here on the map. So it's loading now. So if you look, you can see the points now are showing up. If you're from Lagos, I know you'll be familiar. That's the University Road here, Akoka Road. So the point is kind of close. That's the second point now. So the first point is here, a little bit far away. So it's in Yaba. So we are still in Yaba here. Iwaya, Onike, Tatala is something like that in Lagos. Okay, I don't know. So, but that is the point. So it's now been represented on the map for us to see. So that's beautiful. So it's so easy, and you can see it's more or less we're speaking in our language using R. So I'm giving you the data, convert it to a simple feature data type for me, then show it on a map. So that's the 3 things. This is my data. I'm converting to a geometry, and I'm also going to the next step using the pipe. Just like a pipe, I'm pushing things into my pipe, and the output comes at the end of the pipe. So that is where my map view comes in, and I have the results here now. So now let's be more practical now. So we are looking at getting the data. I'm going to be making reference to grid tree data, and I believe Dr. Olubaya mentioned something like that, and the African Geoportal also have reference to the grid tree. They are kind of the agency, kind of organization, kind of taking charge of the maps, the mapping of this major critical information about in Nigeria. So we can go to the browser now to view the grid tree website. Let me take you there. So if we take the address, so let me take you to my browser, and we'll have a look at that. So, okay, look this. Okay, so can you see my browser? Please let me know if you can. So I've taken you out of the R Studio. I'm now in my browser. Please let me know if you can see my browser now. You can just type in the chat so that I'll know we're together. Okay, thank you. Okay. Okay, thank you. So I'll go to my browser again. Okay, so this is the website. Here you can get all the data, that geospatial data in that format that we can work with. So they are available, it's free, you can download it. So if you want to look at data from administrative boundaries, agriculture, commerce, education, energy, name it, all the data are there. So if I select the health and safety, so there's data that is capturing for all the states. So we have Abia ambulance emergency, Abia fire station. All these are all information that are captured for all states. They've done a great job there. They've captured a lot of data. So when you're now looking at this, you just okay, if I want to get data for ABIA ambulance emergency services, so I can just select this. There is going to be selected in this pop-up. So we have different formats for the data that you can download. They are all free to use. So you can download it as a GeoJSON file, which is better, or you can download it as CSV, GeoPackage, SQLite, different formats, whichever one. If you want to use the shape files, you are free to select that. But if you select the original one, that is what I'm using today. So you also get the metadata that gives you more information about the data. All you just need is to click the download and downloads the information for you. So you can select multiple points, multiple files, and it's going to get everything together and package as a zip file for you. So it's not that difficult. So I'm not sure how the internet will be fast, but the files are actually not big. They are compressed, so it's easier and faster to download. So I've downloaded some of this data. So the one that I'm particular about is the healthcare facilities. So we might want to make some decision around healthcare facilities. If we're looking at maybe a business sense, like, okay, we have an NGO that want to look at the immunization. How do we plan? We might want to say, okay, do we even know how many healthcare facilities that we have that we can utilize before we even go into the field? Or we want to look at how many schools. If we want to give the immunization now, we have schools. Are we targeting kids, primary schools, secondary schools, or whichever one we want? So if you select education, you can also get information about primary schools, private schools, public schools, secondary schools, tertiary institutions. All these data are available. So it's just for you to get the data and make insightful decisions. We can view it. Geospatial maps, interactive maps helps you to do more than just creating points. You can also create and get information about streets, the roads, the multiple layers, like maybe streams, maybe what could be a hindrance to delivering the service, or what could make it even faster. Okay, so all these are information that are available here. There are other sources that you might want to look at, but I will stick with the grid 3. So I've already downloaded my data. I'm not going to take us much into this. So I'll go back to our studio. So an example is this. For ABIA, I have my files. So there is a lot. I've done a lot of work. So from what you can see on my screen, I have a lot here that I've decompressed and I've merged all this. I'm not going to bore you with that. So, but it's easy to do in R. It's so easy. You can work with data, and I can tell you that it's easy compared to others, but we all have our different likes and dislikes and comfort zones. So there is it. So S feature also have functionalities to help us work with data in GeoJSON. So all the files that I have here, they are all GeoJSON files. Okay, they are in that format. So I'm going to show you here. So the extension for all the files are GeoJSON. Okay, so that is that. So it's a lot. It's a lot. So I've kind of worked on the data, and I've tried to clean them up as much as I'll show you some of these things that I've done here. So it's a lot. If you are downloading all the states one by one, then you have to do a lot of margin. But there is one data set that you can have there that is national. It takes up all the states together as one. Then you have everything together as a single zip file. So, but if you're going to go downloading one by one, then you have to do a lot of binding and all this stuff. So I've done that homework. So we're going straight. So for you to read any of the GeoJSON files, you can use this functionality in the SF package that you can install. All you just need to just pass in the address of your file, and it's going to create it. So I'm going to run this as an example, and we would have, we'll have it in the environment here. I have a lot of, so this is the file now. So let's see the object, the data that has been sent down to us. We look at the class. So we are Abia. So that's the name of the data that I said. So you can see that it's a simple feature data, and it's also represented in the table format as a data frame. Okay, so we can now view it like we're viewing an Excel sheet. So, but if you open the file by itself, you kind of say, is it speaking Greek to us or not? So, but that has been covered up here. So we have all the information here, the ID, so the latitude, the longitude, the contact phone number of the location for that healthcare facility, the contact name, some are missing, most are missing. So we don't need the contact name actually. So we have the routine immunization service status. You can get that information. So you'll be able to make decision. That's a business decision that, okay, this facility, I want the facilities that are having routine immunization services available already or not. So all this information, there are so many information here that you can get more details about in the meta data file that accompany each of the downloads. So if you go into that, you'll see metadata.xml, you get more information there. So there's so many. Then the category of the facility itself, is it a primary healthcare center, a maternity home, different categories that we have there. So then the name of that facility is also available, Ureta, primary healthcare, and so on and so forth. So ownership, is it by the state or the primary? Is it a private organization, private owned healthcare center? All this info, it's so much that you can work with. So it's there, it's available. And now the unique thing here that makes it a simple feature data object is that the geometry here. So it's converted that into a geometrical point for us, so which we can use and map onto our map. So that is what we have there. So this is only for Abia. That's 1,270 observations. That's healthcare facilities that are available there. But we're going to take the entire nation. That's the whole of Nigeria now. So that's where we're going to get that information in now. Yeah, that's a lot. So we have 49,329 healthcare facilities that have been captured that we can work with. So in R, we have a package that now that we have the data, we can now look at, okay, can we put it on a map? So we're going to do that with different ways. There are different packages that you can use. Okay, let me see if I have questions here. Okay, I'm sorry, please wait. Okay, the duration of the class, I think we still have some time, but I'm going to make it fast. Okay, moderator, if you can let us have the time frame. The remaining minutes that is remaining, then can get that. So we can use the ggplot package to view the map. So all I just need is to pass in the data, that's the special, the simple feature data object into it. Then we use the geometry, geom_sf, to view it on the map. So if I run this line of code now, we're going to have it in the plots. So it's plotting it from the latitude against the longitude. So all the points are all on this, the foundation here, and all the points are now located for the Abia, all the healthcare facilities here in Abia states. So we can also view that for the country, the entire country. So that's going to take a while. So also, we can also use the map view that we're familiar with, this kind of the black screen. So we have a lot there. So you can see 49,000 plus healthcare facilities in Nigeria. Some are densely populated, then the points are there that we can see. So, but we can also use the map view. And so that is a bit fast, but for the national, it might take a while. So going on, I'm going to be using for all these healthcare facilities. So it's still loading there. So it's a lot. So a little bit, just give it some time. So while that is working, I'll load this. I'm not going to view this anymore. It's the same thing. So it's going to take a while. So it's a lot of points, so much to view. So from what we can see on the screen, this doesn't make sense. So what we might want to look at is that we want to aggregate. Let's kind of group them by states so that we can make sense of the number of healthcare facilities per state. So one thing you should know is that the data object that we're working with is a simple features object. Because of the geometry variant column there, the aggregation will not work. It's still going to return back what we have here. So what we can do, a work around that is that because all the geometrical points are still going to be returned. So if you can see now, everything is still back, although we've grouped by states. It's already grouped by states. All the numbers are being, you can see those ones that are having more than 2,000, those ones that are 1,000 plus, they are colored based, that's the legend, you can see the color variation. So this still doesn't make sense. It doesn't show us that it's grouped and the aggregation has been done. So what we can do is that first we convert this simple feature object to a data frame that we can now group. And for us to do that, all the geometrical points are for what? They went down to local government. It's points. We're talking about healthcare facilities. So each healthcare facilities, even in the community, in the local government, we can have more than 3, 4, 5. So all these points are now clumped up together. It doesn't make sense, although we can see the colors, we can see, show us, okay, variation in, okay, there are so many here, there's list, but let's just aggregate. So to work around that, we're going to convert first into a data frame. So we take out that SF functionality there. So it's no more a simple features data object. So we're going to do that here. We select that and we take out the geometry. That's the last column there. We're not going to take that. So from column 1, we have 25 variables. So we're going to go for 24, excluding the geometry column. So then we'll now combine a different data set that is going to give us points for the states, representing the states itself. So we don't want just the healthcare facilities, we want just the states. So that's where I've brought in an external file to help us do that. So I'm going to run this. So this is helping me. Then one thing you should know is this. As a data scientist, you can't run away from cleaning your data. So the data that I got externally is having different names. So when I tried to create my project, I got into trouble because there's name variation. This one was representing Federal Capital Territory, while on the grade 3 data set, that was the FCT, I think they represented, yeah. So they represented the states, the capital territory as FCT instead of the full name. So it's FCT here all through. You can see FCT and not this stuff. So yeah. So this is the state's name, FCT. So it's not the full name. So I had to do some cleaning there to get the data into the right format so that you can merge them together, join them. So that's what I've done here. So that has been done. I'm not going to go into that detail because of time. So then we're going to group now. We do the aggregation. Then we can now view using the map view. So this instance, I've done add some further more arguments to help me make sense of my data. So the point now is representing the total for healthcare facilities in each of the states. So it's no more by healthcare facilities, but you can also go do the aggregates by the category of healthcare facilities, is it primary, is it private, or all these can be done. But for today, it's just about the states at the state level now. So you can, if you go on, you can see The information is there. The state is Castina. The number of facilities is 2,282. Let's look at Lagos. How many do we have? The 2,387 healthcare facilities in Lagos. So all these are information. You can see this is interactive enough for the introductory class. So you can, that's going to be the end. We have a beautiful, from our agenda, we have a beautiful map that we can showcase here, but this is not the end of learning about creating map, interactive maps in R. There's a lot of opportunities for you to do more, but this is going to be the end of the introduction for today. You can get more reference to the packages that I've used from this link, so you can check out more on that. So at this point, I'm going to say a big thank you to all of you for staying there with me. Thank you for joining me. And then thank you to DSN for this opportunity. So thank you. So Tejumola, let's see, do I have questions here? Okay, thank you, Chidiebere. Thank you. Thank you, Victor. Thank you. Yes, you can ask questions. Please ask questions now. I'll take your questions. Please go ahead and ask your questions.
Thank you very much, Bilikisu. Okay, so if you have any question, you can just drop it, and then I can read it out for Bilikisu to pick.
Okay, so am I permitted to share my email here?
Yes, you can.
Yeah, so in the chat box, yeah, I'll share am I permitted to do that? For those who want to join the R user group to learn more.
Yes, you can. You can drop your email.
Okay, thank you.
Okay, so thank you very much, Bilikisu, for this awesome session. I am sure that I have testifier in the house who can actually testify to this. So we're very glad to have you. So let me quickly check if you have questions, and I can quickly read them out. Okay, will you share the house script for this introduction? Okay, Bilikisu, yeah, definitely. She will share with us, and we're going to share with all registered participants. Okay, so I want to say thank you very much. In the absence of further questions, okay, everything, all the resources will be shared, JJ. So all the recordings will be shared. So in the absence of question, okay, I am aware that we all know about the Meta project, the geospatial project that's going on. Yeah, so I want you to participate. Bilikisu also mentioned it. Okay, and then this class we actually facilitate and give you a leverage to the class, and also to be able to win the cash prize attached to the hackathon. So let's get ourselves ready. Next week, tomorrow by 11, we'll be having another section. Okay, so just stay connected to get updates from us, especially if you have registered. Okay, I don't register, I just joined the link from the group. I did not register, I just joined the link on the group. Okay, oh, you need the registration link. So this will be shared with you. Let me quickly do that. Okay, so that I can just share the link. Jeremiah, I don't know if Jeremiah can just help us to drop the link to register for the geospatial class. Okay, so as Jeremiah does, as I wait for Jeremiah to drop the link, I want to say thank you once again, Bilikisu, and then thanks to everyone for joining this section. It has been awesome, and it has been interesting, impactful, and I can't wait to have a lot of R users in the house and a lot of people in the R community. Okay, so thank you, everyone. Thank you very much. Thank you. The link has been dropped, so you can just join using this link that has been dropped. Okay, so everyone, have a fulfilled day. Blikisu, have a fulfilled day. And okay, bye for now.
So bye. Thank you, everybody. Thank you.